Welcome to solverfy.
.82. Almost all of naturally occurring uranium is uranium-238, and most of the rest of it is 235. And we're imagining that today we have a sample of uranium that's 0.72% uranium-235, and the rest is 238. And so we want to find out what the percentage of that, what percentage of the sample would have been uranium-235 1 billion years ago, and what will it be 100 million years from now? So just to make this sort of easier, let's assume that today, because we're not told what the size of the sample is, and like we could do it just in terms of like percentages and stuff, but since the total amount changes over time, it's a little bit tedious. So let's just say we have a 100-gram sample, and because at the end of each part we're doing a percentage, it sort of doesn't really matter what arbitrary amount we choose. So 0.720 grams of the 235 today. So we have our usual decay equation, n equals n naught e to the negative lambda t. Now, with this case, we know what n is, because that's the value today after a billion years has elapsed. So we just want to solve this for n naught. So we just get e to the positive lambda t. So for the 238, and we can, the number of atoms is proportional to the mass, right? So we can just directly put in our 99.280 grams for 238 and 0.720 grams for the 235, and it'll all work out. So we get 115.94 grams of the 238, and 927 grams of the 235. And so this works out to be 1.63% uranium-235. So we can see that we had a larger fraction of uranium-235 in the past, which makes sense because we can see from the difference in half-lives here that the half-life is almost 10 times less for uranium-235, so it decays faster. And so more of it has decayed since, a billion years ago. And so the percentage of it in the sample should have been higher back then. And similarly, we should expect that, 100 million years in the future, there's going to be an even lower percentage of the 235 because, again, it's decaying faster. I think that direction is maybe a little bit more obvious. So now we just run this calculation in sort of the usual way. We're looking into the future rather than back at the past. So we'll have 97.752 grams of our uranium-238, and we'll have 0.6525 grams of our uranium-235, and so 100 million years from now, this sample is going to be 0.663% uranium-235 out of the uranium that's present. Obviously, all of the uraniums that have decayed since the sample was a billion years old, and then 100 million years into the future, obviously there's going to be other atoms in there. But out of the uranium in the sample, it's going to go from 1.63% uranium-235 a billion years ago, 0.72% uranium-235 out of the total uranium today, and then 0.663% in 100 million years.